Hello everyone, Kushali this side. If you are looking for tech related content, you have come to right place. In this video, we are going to explore IoT and few of its models. By the end of this video, you will get to know exactly what IoT is and how models of IoT work. Let's see what is IoT. According to the definition, it refers to the interconnection of physical devices like appliances and vehicles that are embedded with the software, sensors, and connectivity which enables these objects to connect and exchange data. Now, it means a network of physical things or objects sending, receiving, or communicating information using the internet or other communication technologies and networks like computers, tablets, or mobile phones. It enables the monitoring, coordinating, and controlling process across the internet or another data network. IoT is not a single technology, but it is a combination of technologies and domain knowledge. Now you must be thinking, what are the things in IoT? The term things in IoT refers to the anything and everything in day-to-day life that is accessed or connected through the internet. A thing in IoT can be a person with a heart monitor implant, a farmer, an animal with a biochip transponder, or an automobile that has built-in sensors to alert the driver. In other words, any other natural or man-made object that can be assigned an internet protocol, that is IP address, and can transfer data over a network can be considered as a thing. Now let's see what are the characteristics of IoT. Here we are taking 8 main characteristics. First, connectivity. Things of IoT should be connected to the IoT infrastructure. Anyone, anywhere, anytime can connect. This should be guaranteed at all the times. IoT can connect through several wireless devices like sensors, mobile phones, or trackers. Now, second characteristics, intelligence and identity. It says that the extraction of knowledge from the generated data is very important. For example, a sensor generates data, but that data will only be useful if it is interpreted properly. Each IoT device has a unique identity. This identification helps track the equipment and at times for querying its status. Third characteristic, scalability. The number of elements connected to the IoT zone is increasing day by day. Hence, an IoT setup should be capable of handling the massive expansion. The data generated as an outcome is huge and it should be handled properly. Now, the fourth characteristic says that dynamic and self-adapting. It should be dynamic and adapt to changing context and scenarios. For example, consider a camera meant for surveillance and safety. It should be adaptable to work in different conditions and different light hours. Okay. Now fifth is architecture. It says that it is designed to support various devices, technologies and protocols. Its main task is to confirm whether each connected device does not interfere with the others. This ensures the safety and security of each device's data. Now, the sixth characteristic, that is security. With the number of increasing IoT devices, issues regarding the security of the personal data have arisen. There might be a chance of data leakage as a large number of data is collected, exchanged and generated. There is a chance of personal data being transferred without approval, which is a matter of concern. To overcome this challenge, IoT has created networks, systems, and devices wherein privacy is well maintained. Maintaining safety and security is a big dare for IoT. However, it handles it without any disruption. Now, seventh characteristics, that is self-configuring. It is one of the most important characteristics of IoT. IoT devices can upgrade their software under requirements with a minimum of user participation. Additionally, they can set up the network, allowing for the addition of new devices to an already existing network. Now, the eighth, interoperability, it says that it refers to the ability of different IoT devices and systems to communicate and exchange data with each other, regardless of the underlying technology or manufacturer. To achieve this, IoT devices and systems should standardize communication protocols and data formats. Now let's see what are the benefits of IoT. First, increased efficiency. IoT enables devices to automate tasks without human intervention, reducing the need for manual input. For example, smart thermostats can automatically adjust heating or cooling based on the occupancy and preferences. IoT devices collect and process real-time data, enabling faster decision making, which increases operational efficiency across the industries like manufacturing, healthcare, and logistics. The second benefit is cost saving. Smart devices like lighting system, thermostats, and appliances can optimize energy use, reducing waste and lowering utility cost. IoT sensors can monitor the condition of machinery in real life, predicting breakdowns before they occur. This reduces the cost associated with unexpected equipment failures and downfall in industries like manufacturing, transportation, and utilities. Automation of routine tasks through IoT reduces the need for human intervention, cutting down on labor cost and increasing productivity. Third benefit, enhanced customer experience. IoT enables companies to collect data on customer behavior, preferences, and habits. This allows businesses to offer personalized services like smart home system adapting to individual preferences or retail stores offering targeted promotions. Connected devices can provide real-time updates on service availability such as ride sharing or delivery services, improving overall customer satisfaction. Now, the fourth benefit is better decision making. IoT generates large number of data that can be analyzed to gain insights into the customer behavior, operational performance, and market trends. These insights allow businesses and organizations to make more informed decisions and optimize processes. IoT enables real-time monitoring for critical systems such as medical devices in healthcare, environmental conditions in agriculture, or energy grid in utilities. This real-time data improve decision-making and responsiveness. Fifth benefit is improved safety and security. IoT connected cameras, sensors, and alarm systems enhance security by enabling remote monitoring and real-time alerts. This is beneficial in areas like home security, workplace security, and public safety. IoT devices such as wearables and connected medical devices connect continuously monitor health metrics such as heart rate and blood pressure, providing early warnings about potential health issues and improving patient safety. Now, the sixth benefit is enhanced productivity. IoT can track inventory, shipments, and real-time products into leading the optimized supply chain management. This improves stock levels, reduces bottlenecks, and enhances overall productivity in industries like retail and manufacturing. Now, the seventh benefit is environmental benefits. IoT enables better monitoring and management of energy used in homes, offices, and industrial environment. For example, smart meters and IoT sensors can optimize energy consumption based on the real-time demand, reducing waste and emissions. IoT sensors monitor soil measure temperature, and crop conditions, allowing farmers to use water and resources more efficiently. This leads to the more sustainable farming practices, conserving natural resources. Now, the eighth benefit, that is scalability and flexibility. IoT systems are easily scalable. It allows businesses to add new devices and expand their networks without the need for major infrastructure change. And IoT also provides the flexibility to manage and control systems remotely from anywhere. It adapts to changing business or operational needs in real time. Now let's see what are the models of IoT. There are mainly four models: request response, publisher subscriber, push pull, and exclusive pair. We will be discussing each of them in detail. The first model is request response model. This communication model follows a client server architecture. The client, when required, requests the information from the server. This request is usually in the encoded format. This model is stateless since the data between the request is not retained and each request is independently handled. The server categorizes the request and fetches the data from the database and its resource representation. This data is converted to response and is transferred in an encoded format to the client. The client in turn receives the response. On the other hand, in the request response communication model, the client sends a request to the server and the server responds to the request. When the server receives the request, it decides how to respond, fetches the data, retrieves resources, prepares the response and sends it to the client. The second model is publisher subscriber model. This model comprises of three entities: publisher, brokers and consumers. Publishers are the source of the data. It sends the data to the topic which is managed by the broker. They are not aware of consumers. Consumers subscribe to the topics which are managed by the broker. Hence, broker's responsibility is to accept the data from the publishers and send it to the appropriate customers. The broker only has the information regarding to the customer to which a particular topic belongs, which the publisher is unaware of. The third model is push-pull model. It constitutes of data publishers, data consumers and data queues. Publishers and consumers are unaware of each other. Publishers publish the message or data and push it into the queue. The consumers present on the other side pull the data out of the queue. Thus, the queue acts as a buffer for the message. When the difference occurs in the rate of push or pull of the data on the side of the publisher or consumer, queues help in decoupling the messages between the producer and consumer. The last model is exclusive pair model. It is a bidirectional model including full duplex communication among client and server. This connection is constant and remains open till the client sends a request to close the connection. The server has the record of all the connections which has been opened. It is also said as stateful connection model, and the server is aware of all open connections. WebSocket based communication API is fully based on this model. Now here comes to an end of this video. If you really liked this video or it found you interesting, please ring that notification bell so you don't miss out on future videos, and make sure to hit that subscribe button. Thank you.